Hello everyone, this is Sindhu. I am currently studying at Sri Venkateshwara College of Engineering. Now I am going to discuss about the subject is mathematics for AV communication. In that topic is difference between Fourier series, Z transform, Fourier transform. Introduction. Fourier series, Z transform and Fourier transform are mathematical techniques used to present signal and function in different domains. These techniques have desired applications in various fields including signal processing, image processing, communication system and control system. Understanding the difference between these transformers is crucial for analyzing the manipulating signal effectively. Fourier series. Fourier series is a mathematical representation of a periodic function using a sinusoidal functions. It decomposes a periodic signal into a series of harmonically related sine and cosine waves. Fourier series is mainly used to analyze and synthesize periodic signals. Z transformer. The Z transform is a mathematical technique used to analyze discrete signals or functions in the time domain. It transforms a discrete time signal into a complex domain, usually represented by a function in terms of complex variable z. The Z transformer is commonly used in digital signal processing and control system analysis. Fourier transform. Fourier transform is a mathematical technique used to analyze signals of functions in the continuous time domain. It decomposes a continuous time signals into its consequence frequency components. Fourier of transformers is widely used in areas such as image processing, audio signal analysis, and communication system. Representation of the domain. Fourier series operates in a time domain and represents periodic signals. The Z transformer operates in a discrete time domain and represents discrete signal. Fourier transformer operates in a continuous time domain and represents continuous signals. Periodicity. Fourier series is a application only into the periodic signals with a fundamental frequencies. Z transform is applicable to both periodic and non-periodic signals. Fourier transformer is applicable to both periodic and non-periodic signals. The figure shows the Fourier series of the periodicity. Signals types. Fourier series is suitable for analyzing and synthesizing signals that repeat over a fixed periodic. Z transformer is suitable for analyzing discrete time signals whether they are periodic or non-periodic. Function transformer is sustainable for analyzing continuous time signals whether they are periodic or non-periodic. Mathematical representation. Fourier series represents a periodic function as a sum of sinusoidal functions with different amplitudes and phases. Z transformer represents a discrete signals as a function of a complex variable z, which can be used to analyze system stability and frequency response. Inverse transformer. Fourier series as an inverse transform that allows the reconstruction or the original periodic signal from the Fourier series coefficients. Z transformer as an inverse transformer that allows the reconstruction of the original discrete signals from its Z transformation. Fourier transform as an inverse transform that allows the reconstruction of the original continuous signals from its Fourier transform representation. Boundary conditions. Fourier series requires periodic signals with well-defined boundaries to accurately represent the signals. Z transformer can be handle signals with finite or infinite duration, providing flexibility in signal representation. Fourier transformer can handle signals with finite or infinite duration, providing a continuous spectrum representation. Conclusion. Fourier series used periodic conclusion to analyze and manipulate periodic signals. Z transformers used discrete convolution to analyze and manipulate discrete time signals. Fourier transform used continuous convolution and to analyze the manipulate continuous time signals. Filtering. Fourier series can be used to filtering periodic signals by manipulating the amplitude and phases of the harmonics. Z transformer is commonly used for digital filter design and analysis. Fourier transform is commonly used for filtering continuous time signals in the frequency domain. Limitations of the Fourier series. Fourier series is limited to periodic signals and cannot represent non-periodic signals accurately. Z transformer is limited to discrete time signals and cannot handle continuous time signals directly. Fourier transformer is limited to signals with finite energy and cannot handle signals with infinite energy. Summary of the Fourier series. Fourier series is used to represent periodic signals in the limit of the time domain. Z transform is used to analyze discrete time signals in the complex Z domain. Fourier transform is used to analyze continuous time signals in the frequency domain. Thank you for watching.